Hello. So we left off last time. We started talking about nomenclature, naming, and we are pretty good as far as schedule-wise, ahead of schedule. So we'll just take our time in practicing these things and go over it a few times. Did we talk about naming when we have a varying charge? Like when the metal has more than one type of charge? We started working on that. Is that where we kind of left off? Yeah, okay, perfect. That's what I thought. So, yeah, so we had named those, blah, 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 blah. We had talked about when we're dealing with one of the transition metals, one of the guys in the center, that it's not enough just to write their name. You have to also write the charge in Roman numerals. So if I'm dealing specifically with copper 2, I need to say copper Roman numeral 2. Copper 1, we would say copper Roman numeral 1. Again, you don't have to have these memorized because we will find the charge of this based off of what we do know, which is the non-metal. So I believe we did that. So let's try this one here. So if we've got MnO2, we want to figure out what the name of this thing is. Well, first off, Mn is manganese, not magnesium. Okay, that's pretty common to get those mixed up. Manganese has an unpredictable charge, so we need a Roman numeral. And then the oxygen, we're going to write as oxide. So now we need to figure out the charge. Oxygen is O. Oxygen has a 2- charge, and we always have 2 of them, or in this case, we have 2 of them. So we're going to multiply it by 2, so it's a 4- charge. So then this would have to be a 4+ charge, or manganese 4 oxide. Okay, so identify the cation and anion, balance the charges, and write the correct charge for it. So write the chemical formulas for these here. So I'm giving you the name and I want you to write just the chemical formula. Okay, so for the first one, we have nickel 2 sulfide. So I like to write my metal symbol, and then I'm going to put the charge. And if you've got nickel and you start going over to your periodic chart and going, oh no, what's the charge on nickel? How am I going to do this? Remember, that's why the reader or the writer wrote this for the reader. So we're going to put a 2 plus for that nickel charge. If it was a 1 plus, it would say nickel 1. The 2 does not tell me how many nickels I have. It tells me the charge of the nickel. Sulfide is referring to sulfur. Sulfur always has the predictable charge of 2 minus. So we'll flip-flop. It'll be a 2 to 2, which we can reduce down to 1 to 1. So we should end up with NiS. Zinc chloride. So zinc, you write your symbol out, and then you may be thinking, oh, I'm looking at the periodic chart, and I don't know what its charge is. Where is its charge? And it's not written here. Oh, no, what's going on? Zinc is one of those few that you have to have memorized, right? So zinc is a 2. Silver is a 1. Just remember aluminum, 3, 2, 1. It is zigzag. So 2 plus for this guy. Chloride is talking about chlorine. So we'll flip-flop from there. We should have ZnCl with a little 2. Iron 3 oxide, Fe, is a 3 plus. Oxygen, O2 minus, flip-flop, Fe2O3. What I see a lot of times happening, write it in red because it's incorrect, is people will say, oh, iron, and oh, I've got 3 of them, and then oxygen will 2 or something like that. Okay, so we're done. No, you got to make sure that you're writing out the charge first and then flip-flopping from there. Great. Okay, we're just going to do some more practice with this before we get into polyatomic ions. I'm also teaching nomenclature right now in my 092 class. So I'm going to give you names, and I want you to write the formulas, and then we'll do formulas to names. Okay, so names so far, let's see, we'll do lithium fluoride, silver oxide, copper 3 nitride, rubidium bromide, chromium 2 phosphide. And we'll do that. We'll do 5. Okay, lithium fluoride, silver oxide, copper 2 nitride, rubidium bromide, chromium phosphide. I'll give you about 5 minutes till 11:20 to get those completed. And obviously, if you have any questions while you're working on it, let me know. Okay. Let's go over these guys. So this is a mixture of, all of these are ionic. So they're all going to follow the system that we've learned thus far. There's a mixture of type 1 predictable charge and type 2 unpredictable charge. So first thing we got going on here is, sorry, Josie, want to go outside? Okay. Okay, so we've got lithium fluoride. So write your metal with its charge, and it is so not 2 plus, it is 1 plus. Thicken this pen too. Okay. We've got lithium with a 1 plus charge. Fluoride is talking about fluorine with a minus charge, flip-flop, LiF. Silver oxide, Ag. This is one of those that you have to have memorized. Plus charge, oxygen, 2 minus, flip-flop, Ag2O. Copper 3 nitride. Okay, we're dealing with copper, and it's the 3 plus charge. Nitride is nitrogen with a 3 minus, flip-flop. We would end up with Cu3N3, which we can reduce down by 3. So it becomes CuN. Rubidium bromide. Rubidium, oh my gosh, where's my brain? Rb? Yeah, Rb. Plus bromine, Br minus, flip-flop. We get RbBr. Okay, last one, chromium, Cr with a 2 plus. Phosphide is talking about phosphorus, which has a 3 minus, flip-flop, Cr3P2. You guys getting those? Anyone wondering where some of those numbers are coming from? This is the time to ask. You can throw it in the chat if you're like, where is that 3 coming from for the nitrogen? Why are we doing this? Let me know, because I want this to feel easy. When you're done, I want to be like, I want you to think, oh, God, I don't want to do any more of these problems because it's so easy. Okay, let's go the other direction. So I'm going to give you some, what we got here? What did you do with the copper and nickel charges? Okay, so we had the 3 and the 3. When you're dealing with a metal and a non-metal, you can reduce charges. Yeah, the division thing. So if there's a 3 and a 3, we can divide each one by 3, or we want the lowest ratio. So if it was 3 and 3, we'd divide it down by 3 to get 1 and 1. Another example is, let's look at magnesium oxide. This thing is Mg with a 2 plus and O with a 2 minus. So when I flip-flop, I get Mg2O2. But because those are both 2, I can divide them out by 2, and the lowest reduction will be MgO. How did I get the charge for bromide? Bromine is in column 7. So look at your periodic chart. See where fluorine, chlorine, bromine, iodine is. Above that column, you should put a -1 charge, because everything in that column forms a predictable -1 charge. Other questions on where other charges came from? Really quickly, we can just go over. So column 1, where hydrogen, lithium, sodium, potassium, rubidium is, put a +1 above that. Column 2, where beryllium, magnesium, calcium, strontium, barium are, put a +2. The column where aluminum and gallium sits, so the 4th column, so skip the transition metals, jump over to the 4th column, minus boron, because boron's a nonmetal. Aluminum, gallium will have a 3 plus charge. Column 4, where carbon and silicon are, you don't have to put anything. Column 5, where we have nitrogen and phosphorus, put a 3 minus charge. So those guys like to form a 3 minus always. Column 2, where oxygen and sulfur are, put a 2 minus. Column 6, where oxygen and sulfur are, put a 2 minus. Column 7, where fluorine, chlorine, bromine, and iodine are, put a -1. And then above the noble gases, put a 0 with like a strike through it or something that they don't put out, that did up. They don't form any sort of charge. Does that make sense, Lauren? So for Haley, okay, so zinc is a, great, Lauren. Haley, for zinc, it's a 2+, okay? For silver, it's a 1+. I don't even know, what is cadmium? Is it 1+? I think it's 1+. 2+, thank you, Abigail. Cadmium's a 2+. Oh my goodness, okay, so zinc, 2+, cadmium, 2+, silver, 1+. You had 2+ for all of them for some reason. Yeah, no worries. Any other questions? Don't be shy. Yeah, the carbon column, Courtney, is because those sit right in the middle of a filled shell, they can sort of either add 4 electrons or subtract 4 electrons. And in general, they just tend to share electrons. So they don't really do the whole transfer thing. They tend to just sort of share. So we'll see those guys, carbon and silicon, more in the molecular. And then we have tin in there and lead, number 50 and number 82. Those guys have varying charges. Figure 6.2 under ion charges has a charge for the variable ones. There is a charge, but you don't have to memorize those. Yeah, you don't have to memorize the variable charges. Great. Okay, awesome. So if there are more questions, throw it in there. If there aren't, we're going to expand a little bit on this and start talking about everybody's favorite, polyatomic ions. Gotta love some polyatomic ions. They sound scarier and look scarier than they actually are. I don't want you, I know, editor. Okay. So this thing right here is called sodium chlorite, not sodium chloride, sodium chlorite. So if you notice, it ends with an ITE. That little shift in letters is very, very important, because in this case, we're talking about sodium combined with the chlorite ion. Chlorite is an example of a polyatomic ion. Let me move this stuff out of the way. Polyatomic ion. So poly is many, right? Polytheist, many gods. Polygamist, many spouses. Atomic is atoms. And then ion is just it's charged, right? So many atoms that are charged. So it's going to be a group or a packet of atoms that you're going to treat as a unit, and that unit has an overall charge to it. So this is sodium chloride. It's used for bleaching and different things with like papers and cardboards. Polyatomic ions, so it's a group of atoms with an overall charge. The grouping of the atoms is the same, the charge is the same, okay? It often consists of a couple nonmetals, such as phosphorus, sulfur, carbon, nitrogen, and then it's mixed with a certain amount of oxygen. The charges usually are -1, -2, and -3. There is one positively charged polyatomic ion, and it's called ammonium. Ammonium is NH with a 4 and then a plus charge. Now, when you write this NH4 plus, I want you to get in the habit of seeing where subscripts and superscripts are, okay? Subscripts is talking about number of atoms. Superscript, the thing up here, is talking about charge. So this isn't saying NH with a 4+ charge. It's not saying NH with 4 positive hydrogens. It's saying that there is an NH4 or 1 nitrogen with 4 hydrogens. And they have this packet of atoms has an overall positive charge. So the positive is talking about this as a unit. If we were to break this up, it wouldn't have that positive charge anymore. Okay, so in a plaster cast, you've got this thing here called calcium sulfate. There's a calcium atom and then a sulfate ion. Sulfate is 1 sulfur, 4 oxygens, and that whole thing, again, I'm going to circle this. This whole thing has a 2- charge. All right, so treat the thing that's in the circle as a unit. Just like you wouldn't break up the C and the A of calcium, don't break up the S and the O4 of sulfate. Here's another thing. This is a type of fertilizer, ammonium nitrate. We've got actually 2 polyatomic ions here. Here's ammonium, and here's the nitrate ion. How do you know the polyatomic ions? You memorize them. That's it. Okay. There's like some tricks on the periodic chart, but really just memorize them. But you guys are lucky because you get a little extra help this semester. So have a polyatomic ion sheet available with you. There should be one in your text. If you don't have the text, you can literally go to the internet, which we'll do together here, and just type in polyatomic ions, and print yourself out one of these images or sheets, and it'll have all the polyatomic ions that, I don't like that one. What is that other one? I like the other one. I like this one. So here's one that has all the different polyatomic ions that you would see. How many polyatomic ions are there? There's like so many out there, but you'll see similar ones like over and over again. We do sulfate, we do nitrate, we do acetate, we do phosphate, we do cyanide, we do hydroxide, we do ammonium a lot. So, again, you got a little extra help this semester, whereas you don't have to fully memorize them, but you need to be able to identify them. You think the next slide has a list? Yeah, let's check and see. There's one. Perfect. Okay, so the ones containing hydrogen, hydroxide is really the only one. We use that one a lot. And we'll see that come up a lot when we get into acids and bases, because in some ways we define a base as producing this OH. Nitrogen, we've got ammonium, nitrate, and nitrite. And we'll talk about how to relate the ates and the ites in a little bit. Chlorine, we've got chlorate, we've got chlorite, we've got this thing called hypochlorite and perchlorate. So the way that ATEs and ITEs work is, and we've got some other ones, sulfate and things like that. Okay, so when we look at the sort of the chlorine oxygen oxyanion set, chlorate in this case has 3 oxygens. ATE does not necessarily mean it has 3 oxygens. It just means that it has 1 more oxygen than your ite, okay? Or ITE will always have 1 less oxygen than whatever your AT is. So if you know that chlorate is ClO3-, then the chlorite, you strip 1 oxygen away to get the ITE. That doesn't mean you change the charge. Charge stays the same, you just take an oxygen away. If you go from chlorite and you want to take it to 1 more or less oxygen, you become hypochlorite. Hypo meaning under, like hypoglycemic. So hypo meaning 1 less oxygen than the ite. So it goes hypochlorite, then we go to chlorite, we add an oxygen, it becomes chlorate. What if we have an additional oxygen from this? It becomes perchlorate. Okay? But this does not associate with the number of oxygens, it's just their relationship to each other. I can show you an example where we have, let's see. So we had talked about sulfate. Sulfate is SO4 with a 2- charge. This is sulfate. It ends in ATE. It has 4 oxygens. This one ends in ATE. It has 3 oxygens. So again, the ATE doesn't necessarily tell you how many oxygens you have, but if I was to say, hey, this is the formula for sulfate, what is it for sulfite? You know, come on, we can do it. Sulfite, we know that if we're dealing with ITE, we just strip an oxygen away. So sulfite will be SO3 with a 2- charge. Okay, that's how those things relate to each other. So those little details, is it an ATE, is it an ITE? Super important. But know that if you see ATE or ITE, you're definitely dealing with a polyatomic ion. You want to be referencing polyatomic ions. Sometimes when people see things like sulfate, they're like, oh, it's got the word sulfur in it, sort of, so it must be sulfur. Well, sulfur is there, but there is also 4 oxygens, okay? So the most common ones ending in ATE, sulfate, phosphate, nitrate. Phosphate, PO4, 3-, big charge on this guy. The ITEs all have 1 fewer oxygen than the ATEs. So if this is sulfate, sulfite better just be the same thing with 1 less oxygen. If this is phosphate, phosphite better be PO3 with a 3- charge. Keep the charge intact, just drop the oxygen. Cyanide does end in IDE, and so does hydroxide. Those are talking about polyatomic ions. So you just have to get used to identifying cyanide as a polyatomic, and hydroxide is not hydrogen, it's a OH-. We can take something like, for instance, carbonate, and if I add a hydrogen to it, hydrogen has a plus charge. You can see it's in column 1, it likes to form a +1 charge. So if I take carbonate and I add hydrogen to it, I get something called, you can name it either hydrogen carbonate or bicarbonate is usually what we go with. Because this has a 2- charge and this has a +1 charge, the overall charge on your combined thing will be 1- because this is sort of stripping away one of those 2's. Same thing with sulfate. If I want to go to bisulfate or hydrogen sulfate, HSO4, it'll have a 1- charge because one of these negative charges is counteracted or balanced with the hydrogen. So any questions on polyatomic ions outside of like you just have to memorize them or be able to reference them? Things ending in ATE, ITE should push you in the direction of looking at polyatomic ion. Okay, so let's talk about how those combine. So if I have something like magnesium and nitrate, we can do the exact same thing we did before with the flip-flop rule. They don't really set the flip-flop rule up here, but so I'm going to do it the way I've been teaching y'all over here. So magnesium is Mg with a 2+ charge. Nitrate is NO3 with a - charge. It may help you to circle this without the charge, keeping the charge on the outside, just to sort of remind yourself, this is a packet, this is a packet, this is a packet. I don't want to break this up. So flip-flopping, there's a magnitude of 1 here, so I should only have 1 magnesium, but I have a 2 here, which means I need to have 2 nitrates. So how do I represent 2 nitrates? Well, I put the nitrate ion in parentheses, the whole thing, and I put a 2 on the outside of it. Okay, so this is denoting that I have 2 of these to balance out 1 of these. What I see happen sometimes is people will write, okay, Mg2+, NO3-, let's flip-flop. And they'll go Mg, NO, and they'll take this 3 for whatever reason and change it to a 2. because they're seeing the 2 here and they're sort of flip-flopping, but they're leaving that out. That's why you want to circle this to remind yourself this cannot change. This is nitrite and it's not even balanced correctly. So this is just wrong. Another thing I'll see people do is they'll go, okay, I have MgNO3 2 and not put the parentheses in. Why is that one not correct? Well, because now you have 32 oxygens the way that it's written. So we don't want that either. So we need to make sure that we're putting those parentheses in if we have more than one. If you only have one, you don't use parentheses, okay? So let's see what the slides have to offer. Okay. Aluminum bicarbonate. All right, let's do it on a different page. Clear these all out. Where would the +2 charge go on magnesium, Janine? In that previous one where we had Mg2 plus and NO3 with a minus charge, we flip-flop charges. So the 2 will become the amount of nitrates we have. The 1 over here will become the amount of magnesium. So it becomes Mg parentheses NO3 2. So the 2 gets dropped here. The 1 gets dropped here. Does that make sense, Janine? Okay, cool. Cool. Yeah, sometimes it's hard to, you're like, where did that number come from? What is she talking about? So yeah, ask me. Aluminum bicarbonate. Okay, so aluminum, Al, always has a 3+ charge. Bicarbonate is this HCO3 with a minus charge. I'm going to circle this thing for now. You don't always have to do that, but just sort of to get in the habit of seeing that as a packet. So this has a magnitude of 1, so I should only have 1 aluminum. This has a magnitude of 3, so I need 3 of these packets. So I'm going to put a parenthesis HCO3, and this sometimes throws people off. They're like, ooh, should I put another 3 here? Yes, you should put another 3. You have 3 of the 3 things. Okay, so there's 3 oxygens and you have 3 of them within that. Let's do calcium phosphate. I want you to try that. Okay, so for this one, calcium phosphate, we're going to write our metal with its charge. Calcium has a 2+ charge. Phosphate I see that ATE in my mind, I'm going to say, okay, ATEs, ITEs, it's some sort of polyatomic ion. I mean, obviously it's polyatomic ion because we're working in that section of the chapter, but when you're on a test, it all sort of gets jumbled together. So identifying, okay, I need to see what my polyatomic ion is. It's PO4, and it has an overall 3- charge. I'm going to circle this thing so I can keep it together. Flip-flop my charges. So the 3 is going to become the subscript of the calcium, Ca3. P, whoa, don't want that. P, come on. There we go. O4. And the 2 will become the subscript of my PO4. So this gets dropped down here. This gets dropped down here. So it's the same system that we've been doing. We're just sort of expanding our definition of things, like where we had column 1, column 2, column 3, column 4, column 5 with their charges. Now you've got a list of polyatomic ions with its charges as well. The charges won't change on the polyatomic ions. So sulfate will always have a 2- charge. Phosphate will always have a 3- charge. This works for transition metals as well with polyatomic ions. So if I've got iron to nitrite, iron in this case, Fe, you start looking at the periodic chart. Where's its charge? Where's its charge? It's written right there. Okay, so 2+. Nitrite, again, ITE is a polyatomic ion. So NO2 with a minus charge. We're going to keep this as a unit. Flip-flop, Fe, parentheses, NO2, 2. I'll give you 2 more with the varying charges, because I feel like that's always sort of a weak spot for students with naming. Cobalt 3 carbonate, and no, I want to do an unpredictable charge, sorry. Nickel 1 cyanide. Okay, so cobalt 3 carbonate. So that means we're dealing with cobalt, and in this case, we're dealing with cobalt that has a 3+ charge, not that we have 3 cobalts, but that it's got a 3 positive charge. Carbonate, polyatomic ion, CO3 with an overall 2- charge. So I'm going to flip-flop here. Cobalt, I should have 2 of them. Carbonate, I should have 3 of them. Nickel 1 cyanide, so nickel Ni, in this case it has a +1 charge. Cyanide is a polyatomic ion with a minus charge. 1 to 1, flip-flop, it'll be NiCN. That looks weird to me, but that is what it is, in fact. That's why it looks weird, because it's a C. Let's go with N. It's like, why does that not look right to me? There we go. That also looks weird, but it is what it is. Okay. Questions on that? Now, so what you may have noticed when I've been naming these is that I just sort of smush the polyatomics name on at the end. I'm not changing that at all. And that is, in fact, the way we do it. So let's see if it gives us some more practice here. Compounds of polyatomic ions. Guide to naming compounds with polyatomic ions. Yeah, let's do that real quick. Okay, so if we're going to name it, identify the name of the cation, or identify the cation and the polyatomic ion, name the cation using a Roman numeral if needed, and then name the polyatomic ion, and that's it. So we don't change the polyatomic ion's name. We don't IDE it, we don't truncate it, we don't do anything like that. So when I see something, well, I'll just write a couple out. So if we're going the other direction, and let's say I have something like this, FeCO3 LiNO3 NiSO4 and CO2SO4. Okay. So if I'm going to name these, I'm first going to say it is in fact a metal with a non-metal or polyatomic ion. So just like we did before, this has an unpredictable charge. So I'm going to write iron. I'm going to put a parentheses and I'll come back to it. And then this thing here is carbonate. If you ever are in a place where you're looking at it and you're like, oh, there's just too many different types of atoms, I don't know how to name this, it's probably a polyatomic ion. You start going, oh, that's like iron and then carbon trioxide. How do I call it? It's probably a polyatomic ion, okay? So let's put a line between this. Carbonate always has a 2- charge. So iron has to have a 2+, and there's only one of them. So it takes in the full charge, iron 2 carbonate. This thing here, we have lithium. And we've got nitrate. That's the polyatomic ion nitrate. There's no Roman numeral for that. Here's nickel and here's sulfate. Nickel, we need to identify the charge though. I'm just going to write sulfate. That line is supposed to be over there. So sulfate is always a 2- charge. So this nickel is a 2+. So we're at nickel 2 sulfate. Cobalt. CO2SO4, this is going to be cobalt, some sort of charge, and this is also sulfate. Right, so this here is a 2- charge, this has a 2+ charge, and it's divided amongst 2, so it's actually cobalt 1 sulfate. So I'm going to write a couple things that sound very similar, but we'll have different formulas. So I want you to write the names for FeS, FeSO3, NaSO4, I'm going to put 2 there, Na2S, Okay, I think that will get the point across. Oh, and sure, why not? Let's do one more. We'll put it over here. FE to S. Give you just one more minute. Wrap up at 12. Okay, so this first thing is iron, which has an unpredictable charge combined with sulfur, which becomes sulfide. We IDE it. In this case, we've got a 2 minus, so this is a 2 plus. So this would be iron 2 sulfide. The next thing is iron, which has an unpredictable charge, with the sulfate ion. So sulfite ion rather, sorry. This ITE. This thing has a 2 minus, so this has a 2 plus as well. So this is iron 2 sulfite. So seeing that sometimes these things can sound very similar, iron 2 sulfide, iron 2 sulfite, but talking about two different things. This here is sodium, which has a predictable charge, so I don't need to write anything. And this is the sulfate ions, the sodium sulfate. This is sodium, which has a predictable charge with just sulfur. So that's sulfide, IDE, AT. This one over here, sodium sulfite. Oh my goodness. So many ites and eights and IDEs. Little details though that are important. You know, multiple choice test, if I give you one of these formulas, you probably can assume that some of these other ones will be on there to throw you off, okay? Last one here, we've got iron, unpredictable charge, and this is sulfide, IDE. 2 minus charge, 2 plus charge, but there's 2 of them, so iron 1 sulfide. Iron 2 sulfide, iron 2 sulfite. So many little details in there. Any questions on those? I wanted to give you some that kind of sounded all the same. Yes, no, maybe so. You got it. You're experts, naming experts. Jordan, hopefully you are. Hopefully you still got it from last semester. Jordan was a rock star in naming last semester. The iron confuses you. Why wouldn't it be iron 4? For which one? The first one, Abigail, or the second one, or both of them? This one right here. Okay, so let's just break it down a little bit more then. And know that if you have a question on something, there are other people that have the same question for sure. So F2O. All right. No, it wasn't even O. It was F2S. Let's make that an S. Come on, just give me a break. Okay. So this whole molecule has to equal a charge of 0. Are you good with that? All right, so what we have is a negative side and a positive side. The negative side is coming from the sulfur. Sulfur has a 2 minus charge. I'm gonna write it down here. 2 minus, and how many of them do I have? I have 1. So it's an overall 2 minus charge. So are you good with that side? Okay, so sulfur always has a 2 minus charge, so that'll be 2 minus. Now that means that this side has to equal a 2 plus charge. So iron, there are 2 of them. So I have to take whatever this number is and divide it by how many of them I have. If I only had 1, like I did in that previous up here, I only had 1 iron, so the 2 was just being consumed by the 1 iron. Or the 1 iron is bringing the total of a 2 plus charge. Here, 2 irons have to total a 2 plus charge. So each iron brings a +1 charge. One way you can, and that's probably the hardest thing in this chapter, I see people getting thrown off on. Go over sodium sulfate. I'll go over sodium sulfate as well, yeah. Okay, so once we finish this, so You get it now? Oh, okay, good, good. Then one way you can always check it too, Abigail, is let's say you were like, I'm going with iron. No, iron. I'm going with iron 4 oxide sulfide. I'm going with iron 4 sulfide, and that's, you know, and you could say, oh, I always get these wrong. I think it's iron 4 sulfide. You can go back and check. And if we go back and check, if it's iron 4 sulfide, that means that iron, Fe, is going to have a 4 plus charge. Sulfur is going to have a 2 minus charge. If we flip flop that, we get Fe2S4, which reduces down to FeS2. Is this the same formula as this? It's not. So that's one way to check. Okay, Lauren, what did you say? Sodium sulfate. All right, let's go over that. So we had Na2SO4. So when looking at this, I've got a metal and I've got a polyatomic ion. There's 2 units. This metal is sodium. I don't need a Roman numeral. I don't need to put a parentheses. Why? Because where sodium sits on the periodic chart, it's in column 1, which is a predictable charge. So I know sodium always has a +1 charge. Was it Na2? Was it not? Did I leave the 2 off? Let me see. Na2, yeah, Na2SO4. Why is it Na2SO4? Well, we'll go back the other direction in a second. I'll show you. So as far as naming is concerned, sodium, we don't need a Roman numeral, and this hunk of atom here is known as sulfate. That's its name. Sulfate. Why did I write the formula like this instead of, say, like this, NaSO4? That's incorrect. Sodium has a plus charge, sulfate, SO4, 2 minus charge. I need 2 sodiums for every 1 sulfate. Okay, that's why I wrote it that way. Courtney, does that make sense? Lauren, does that make sense? If not, let me know. I can go over some more in that field. Wrote it down around the first time. Okay, cool, no worries. Lauren, you got it? Okay, perfect. So I think we're gonna break for there right now. There is some more naming. We've got to do all the non-metal stuff, but that I think is much easier than this. So next time we'll talk about non-metals, and then we'll mix them all together and just have a bunch of fun with naming. I recommend practicing these. You want to be really good at them. They're not going to go away. They stay with us for the first half of the semester at least. And then you get to do a whole new range of naming in organics. Organics is going to make this feel like child's play. So is there practice of this in the homework? Yes, you will have a lot of practice of this with the homework. There's a lot of practice, yeah. And if anyone ever wants more practice, I can always give you more practice worksheets. I have some lying around. Just email me. Yeah, that's all I got. So you guys let me know if you have any questions. Stay around. If you don't have any questions, log off, and I will see you next week or through email. If you need to meet for anything, work on labs or anything, just let me know. Okay. Bye, guys.